Hello and welcome to another fun-filled day in math with Mr. Sims. Today what we're going to be doing is we're going to be talking about how to deal with radicals and really dividing radicals, and also how to deal with radicals in the denominator, right? So we're gonna go ahead, rationalizing denominators, things like that, right? So let's go ahead and get started. So before we get on to this, what I'd like to do is really quickly just go ahead and lay some of a bit of a foundation regarding radicals. So one of the things you can know is this. One second. That basically, when you have radicals, they actually follow a lot of the same rules as variables, right? So like, let's say for instance I had 2x, right? Sorry, let me try and make that a little bit neater for you. Let's say, that's too much probably. Oh, that's too much. Oh, that's way too much. Okay. Let's say I had 2x, right? And I wanted to add to 2x 3x, right? Well, obviously, as you know, that's 5x, right? You basically you have the 2x's and the 3x's, and so now you have 5x's, right? Well, likewise, if I had 2 square roots of 2 plus 3 square roots of 2, it's going to follow that same principle, where I end up with 5 square roots of 2, all right? So it follows a lot of the same things. In fact, you can imagine, sorry, if you see some radicals, let's say you were to see 2 square roots of 2, right? And well, let's say you wanted to add to that, you know, like what? 3 or subtract from that 3 square roots of 2, right? Once again, you could think of that and say, okay, well, what if I made the square roots of 2 x's, right? Minus 3 square roots of 2. And that would give you, minus 3x, right? And you would say to yourself, okay, well, that's a negative x, right? So likewise, that's going to be a negative, that's going to equal a negative square root of 2, right? So it's a lot of the same principles, like I said, all right? All right, so now that we know that that's the case, right? Here's like another thing. Notice that if I had, let's say I had, if I had 2x plus 3y, right? I can't add those together, right? That's actually as simple as it gets, 2x plus 3y. Likewise, if I had 2 square roots of 2 plus 3, this y would not be square root of 2, right? Because if it was square root of 2, it'd be x, right? So this would be like, say maybe the square root of 3. I can't combine these either, just like I can't combine those variables, right? So anyway, you know, that just gives you an idea of how these things work, right? Once again, like let's say I had x squared, right? And I took the square root of x squared, I would get x, right? If I take the square root of the square root of 2, right, squared, well, that's going to give me, I'm sorry, what was I doing? Sorry, I lost track of what I was saying there. But anyway, the square root of that with squared is just going to equal the regular square root of 2, right? Anyway, so this just gives you an idea of just a few different things here, right? I'm basically just trying to lay a foundation for the basics of radicals so that as we work up here, it's not very confusing to you, okay? Anyway, here we go. Let's go ahead and do this right now. So for this one here, I have square root of 2 plus 5 over the square root of 10. Now you're going to notice with all of these problems that I'm doing here, one of the ways to tackle this, because this square root of 10 is in the denominator, right? This has this radical in the denominator. We do not like radicals being in the denominator, at least not in final answers. So as a result, one of the things you notice that we're always going to do is we're going to take and multiply this bottom by the square root of 10. Now I can't just multiply the bottom by the square root of 10. Obviously, doing that would change my expression completely unless I also multiplied the top by the square root of 10. And really, if you think about it this way, really what we're doing is we're multiplying this whole thing by 1 whole. Because remember, 3 over 3 is equal to 1 whole, right? 4 over 4 is equal to 1 whole. And finally, square root of 10, all right, over the square root of 10 is what? It's just 1 whole, right? So what we did was we multiplied this by 1, right? And by multiplying it by 1, we're going to get it into a form that we want to work with. Now notice, because there's 2 terms on top, there's 1, 2 terms, right? I'm going to need to distribute this 10 to both of those terms in that multiplication process, right? So, because essentially what I had was I had the square root of 10, right, times the square root of 2 plus 5, right, if you put it in parentheses, right? So anyway, let's go ahead and do that now. I'll start with the top. So on top now I have the square root of 2 times the square root of 10, right, plus 5 times the square root of 10. So once again, I have distributed that square root of 10 to both of the terms on top. And on the bottom, square root of 10 times the square root of 10, right? So let's look at this right here. Some students are having trouble seeing what that would be, but the square root of 10 times the square root of 10 is really just 10. Let me explain why. Well, remember how I told you they follow the same rules as the x's, right? So if I had the square root of 10, right, times the square root of 10, right? Sorry, the square root of 10, right? That's really 10, the square root of 10 squared, right? This squared and this square root cancel out. But the other way you can think about it is this. That's one way you can think about it. Those cancel out to give you 10, right? The other way you can think about it is this. The square root of 10 times the square root of 10 is going to be equal to the square root of 100, because 10 times 10, you can multiply radicals. 10 times 10 is 100. So the square root of 100, as you know, if you do it in a calculator, is 10, right? So, so that's how I got that 10 down here. So let's go ahead now and move on to the top, where it's just ugly a little bit, right? So I have square root of 10 over the square root of 2 times the square root of 10, rather. 2, so once again, I told you can multiply radicals, right? The square root of 2 times the square root of 10 is going to be equal to the square root of 20, right? And I'm going to add to that this 5 times the square root of 10. Now, I can't multiply these together because this is not under a radical, so this is just going to stay 5 square roots of 10, okay? And this is going to be over 10. Now, I'm not done. If you're looking at that, it's really tempting to want to be done, but I'm not done, because what I still need to do yet is you have to look at all of your radicals. There's 2 radicals left, and I have to ask myself the question, is there a perfect square that I can take out? So if I look at 10, right, we taught you the birthday cake method of simplifying radicals. So let me look at that square root of 10, right? I'm going to try and take out any that I can. I can take out a 2, right? That's a prime number I can take out. I get 5. Then I can take out a 5, and I get 1, which is that birthday candle that I'm trying to get. It's upside down birthday cake, right? So there, as you can see, there's no numbers that are doubled out here. So both of these would still stay under the radical. In other words, what I have is square root of 2 times 5, and really 2 times 5 stays just 10. So really the square root of 10 doesn't simplify, sadly, right? Oh, doesn't simplify, but the square root of 20 does. If I take this 20 over here, right, I can pull out of there, I can pull out 2, right, which gives me 10. I can pull out another 2, right, which gives me 5. When I say pull, I mean I can divide by it, right? I can divide by 5 to get 1, although those are prime numbers, right? Notice, since there's 2 2's out here, those no longer have to stay under the house, right? So I'm going to put those outside the house. Together they become just a 2 outside the house. And whatever is left with no partner is inside the radical, so that's 2 square roots of 5. So that square root of 20 turned into 2 square roots of 5 plus 5 square roots of 10, all over 10, right? And that right there is basically as simple as that can get. The other thing you'd want to check is, can you divide, are all of these divisible by a common thing? And 2 and 10, in theory, I could take out 2, right? I could factor out, but unfortunately this 5 makes that not possible. So if I actually look at my answer, let's double check to make sure I didn't make any arithmetic errors. It happens, right? So let me go ahead. That was problem number 8. Let me look at my thing for problem number 8 and see if I got it right. Did I get it right? Let's see. Did I get it right? Survey says, let's see, problem number 8. Winner, winner, chicken dinner. That feels so good. I love getting problems right. I know you do too. Let's get some more right. Here we go. So I have 4 square roots of 3 minus 4 square roots of 2 over square root of 12. I'm going to move a little faster on this. I figure that we've, at this point, laid the foundation a little bit, right? So I'm going to start, once again, by multiplying by the square root of 12 over the square root of 12. You're going to notice that's the general just concept that we start with, right? And so that's going to give me on the bottom, like I said, 12. Once again, refer to the first problem if you want to see why that's the case. But basically what I have is a I can think of it like 144 square root of 144, which is 12, right? Anyway, you get the idea. But basically, this square root of 12, right, squared cancels out, right, and makes 12, right? That's a 12 underneath there. Sorry, it wasn't clear. Oh, that's just getting worse and worse and worse and worse. So the square root of 12, okay? Anyway, you get the idea, all right? So moving on, let's go ahead and do this some more. So I now have 12 on the bottom, and this square root of 12 on top I have to distribute. Now obviously this is going to get ugly before it gets better, okay? So I have the 4 square roots of 3 that I'm going to multiply times the square root of 12. Now I want you to notice I'm very systematic in my work here. I try to make sure that I'm neat and organized so that I don't make careless errors, okay? Square root of 12. And I'm sorry about the handwriting. Handwriting is not my strong suit, but I make sure I'm good enough so that I'm not going to get a problem wrong just because of my handwriting, right? So 4 square roots of 3 times square root of 12. This 4 isn't going to multiply times this, but the 3 and the 12 can. So this here is going to be 4 times, actually 4 times the square root of 3 times 12 is 36, right? Minus 4 times the square root of 24, all over 12, okay? Well, I'm making a lot of headway here. This is nice, right? And the nice thing, look at this beautiful square root of 36. That square root of 36 is just going to become 6, right? Oh, what was that? What is that? So 4 times 6 minus 4. This square root of 24 here, I can simplify too. That's going to be the square root of 4 times the square root of 6. You might be wondering why I chose the square root of 4 and the square root of 6. And the reason I chose the square root of 4 is because I knew the square root of 4 was a perfect square, and 4 times 6 is 24, right? If I'd broken it up into like square root of 2 and the square root of 12, well, that just doesn't help me much. I'd have to continue to break it down into square root of 2 and square root of 4, right? And then what am I doing? Oh yeah, and that'd be the square root of 6. 2 times 3 is 6, right? But that square root of 4 would turn to 2, right? So I could have done it like that as well. But anyway, I felt like this was more direct, so I just pulled out the square root of 4. So now that I have that, this becomes, I'll put this over 12, right? And then I don't want to skip any steps here, you know? So I now have 4, sorry, let me do this, 4 times 6, which is 24, let me just make that 24, minus 4 times 2, because square root of 4 is 2, right? Square root of 6. And then I'm going to put that over 12. All right, which gives me, finally, geez Louise, 24 minus 8 square roots of 6 over 12. Now, I know that this is not the answer, but I want to show you that if you looked at it, you would say, hey, that looks like the answer, right? And this particular problem was what problem? It was problem 16. So I'm going to go over here to problem 16. I want to show you something. Problem 16, what is the answer? Problem 16, what is this? The answer says 6 minus 2 square roots of 6 over 3. Now I want you to notice that because if you had, let's say you had multiple choice, right? 6 minus 2 square roots of 6 over 3. Let's look at what that would look like here. How did they get that from this? And if you're thinking about 6 minus 2 square roots of 6 over 3, if you were looking at how they got that, you might have noticed that, hey, it looks like all of these were divided by 4, and that's exactly what they did. What they did was they factored out of the top of 4, so they got 6 minus 2 square roots of 6, right, by factoring out that 4, and likewise on the bottom, on that 12, they factored out a 4 to get 3. Now these 4's cancel out, and my final answer is what? 6 minus 2 square roots of 6 over 3, okay? So that's how you do that problem. So once again, when you get an answer, and it looks like it's pretty much complete, once again, all of the radical doesn't have any perfect squares you can take out, right? So it looks pretty good. You still always want to make sure that you can't factor out something, something that on the top and the bottom, right? And cancel it out. Here we go. Moving on. Ding, 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 ding. Let's do this one. -1 minus 3 square roots of 5 over 17. So once again, the pattern, right? You're going to see, take that square root of 17, put the square root of 17 on top, right? I'm going to take, and I'm going to multiply by those. And once again, that's going to give me on my bottom 17, right? On the top, these are going to distribute in, and I end up with the negative square root of 17. Oh, you know what? I'm sorry. I shouldn't have skipped that step, guys. Here we go. -1 times the square root of 17. Don't skip steps, Mr. Sims. Don't skip steps. Because I don't want to confuse you guys, right? Square root of 17. Okay. So there we go. That's the basics of what we're doing. Now what I have to do is actually do that process. So this is going to become the negative, right? Negative square root of 17, right? Minus, the reason I got rid of the 1 was it was unnecessary, right? Minus 3 times, what's 5 times 17, right? Well, that looks like, I think, 85, right? 5 times 17 is the square root of 85, is that right? I just want to verify to make sure I'm not doing an arithmetic error here. 5 times 17. 85 is indeed the correct answer. So -3 times the square root of 85, right? And finally, I'm just going to take that 17 here. And I just put that beautiful, lovely 17 here, okay? Now, if you're looking at that, you're probably thinking to yourself, that is so unbelievably ugly. And you are 100% correct. That is ugly, but that is also the answer. And the reason you know it's the answer is this, right? There's nothing I can take out, you know, there's nothing I can factor out that would help cancel with anything of the 17, right? Also, you'll notice that each of the radicals has, there's no perfect squares that I could take out of it, right? So really, this is the best that I can do. Is it ugly? The answer is absolutely yes. Is it the answer? The answer is absolutely yes, yes. So this is the answer, all right? Now, if you wanted to prove it to yourself, what I would do is I'd do two things to prove it to myself. I would take the 85, right? I know that 17 is a prime number, so I don't have to try and simplify that radical, right? But I could take the 85 and try and simplify it, right? So if I take 5 out, that becomes 85 divided by 5. I'm not going to do that in my head. 85 divided by 5 is equal to 17, right? So that equals 17, right? Where did that go? 17, right? And then I would take out just 17, and that gives me that cute little birthday candle. So because there's nothing that matches, right, these are both going to stay under the radical. So I have 5 times 17 still underneath my radical, right, which is equal to, once again, square root of 85. So I can't simplify that anymore. That's why that's the correct answer. All right, I hope that's making sense to you. Let's go ahead and do another one, right? So 4 square roots of 2 minus 3 square roots of 3 over 2 square roots of 14. So what I'm going to do is I'm going to start by multiplying both the top and the bottom by the square root of 14. And when I do that, I get 4 square roots of 2. Oh, you know what? I'm sorry. Yeah, actually, 4 square roots of 2. Once again, this has to distribute in, right? Times the square root of 14, right? Minus 3 square roots of 3 times the square root of 14. Then I'm going to put that over 2 square roots of 14 times the square root of 14. Those 14's cancel out, so that just becomes 2 times 14, right? The square roots cancel out because it's square root, once again, of 14 squared, which cancels out, right? All right, so now what I'm going to do is, let me go ahead and simplify this further, all right? So this 2 times 14 would make 4 square roots of 28, right? Minus 3 square roots of 3 times 14, which is going to equal 42, I believe, right? Is that right? 3 times, yeah, yes, that's right, 42. And on the bottom, I have 28, right? So, all right, so what I'm going to do now is I'm going to simplify any of these that I can. If I can simplify it, I want to simplify it, right? So let's go ahead and try and pull out of that 4 square roots of 28. Well, 28 can be broken up into, you know what, let's do it like this. Let's take that 28 and just simplify it. So 2, which gives me, what's that? 14, right? So 14, I pull out another 2, which gives me 7. I pull out a 7, which gives me my birthday candle. Yay, right? I feel the need to draw the birthday candle. So these two join together to be outside the radical, right? So 2 square roots of 7 is the simplification of that. So this is 4 times 2 square roots of 7, okay? The only reason I put it in parentheses was to help me see it better, okay? Minus 3, and let's go ahead and do the square root of 42. So let's take that 42, and once again do our birthday cake method. You have 2, you get 21, right? You have 3, you get 7, you take 7, you get, oh, math bad, 1. So, is that right? I didn't mess up anything there, right? Okay, yeah. So, unfortunately, the 42 doesn't actually simplify. So, I just leave that the square root of 42 because 2, 3, and 7, none of them have a partner to leave the house. So, unfortunately, they have 2 times 3 times 7, which really just simplifies once again to the square root of 42. So, we didn't accomplish anything with that. So, moving on. So, 3 square roots of 42, and all of that over 28. So now that ends up equaling what? That's 8 square roots of 7 minus 3 square roots of 42 over 28. Last thing I got to check is, do all these coefficients and stuff like that, do they have a common factor that I could pull out and divide away? And the answer is no. No, there's not. 8, 3, negative 3, really, and 28. No, there's nothing I could take out of all of those. So, unfortunately, that is the ugly, ugly, ugly answer. That is the correct answer for this problem, which happens to be which problem? That is problem number 7. Yeah, so that is the ugly answer. That is that problem. Let's go ahead and do one last problem. This is the last one I'm going to do. I figure at this point you kind of understand the process, right? Once again, first step, I'm going to take and multiply the top and the bottom by square root of 15. Right? You get the idea, right? Square root of 15. All right. So this square root of 15 times square root of 15 on the bottom cancels out. I get 15. These I got to distribute in this square root of 15 though, right? So that ends up with the square root of 2 times the square root of 15, right? Plus 3 times the square root of 3 times the square root of 15. So now it's super duper cool. We can actually take and multiply these together. I end up with the square root of 30 plus, this is 30 by the way, sorry, plus, what's that? 3 square roots of 45. If you're wondering where I got the 45, it was the square root of 3 times the square root of 15, right? Which is equal to the square root of 45. And finally, I have to check one more thing. I always want to check to see if there's any perfect squares I can take out of either of these. If I look at 30, right, I'm going to show you another way of doing this. If I look at 30, right, you know what, let's just do it the birthday cake way. Here we go. So 30 times take out a 2, I get 15. Take out a 3, I get 5. Take out a 5, I get 1. Now that right there, obviously that birthday cake, none of these match, right? None of these have a pair, so everything's going to stay underneath the radical. So really that's 2 times 3 times 5, which is just what we started with, which is the square root of 30, okay? So unfortunately that didn't help us at all. But let's try 45, because why not, right? So if we take out 45, right? You have 5 times 9 is 45. You take out a 3, you get 3. You take out another 3, you get 1. You give it a little birthday candle. And notice I have these dual 3's here. So those 3's are going to be able to leave the house together, you know, the buddy system and all that, right? Square roots of 5. So 3 square roots of 5 is what this 45 simplifies to. So I now have the square root of 30 plus 3. This 3 is not part of this 3. This is the 3 from here, right? 3 times 3 square roots, square roots of 5. And that is all over, 15. So now it's just a matter of simplifying some stuff, right? Square root of 30 plus 9 square roots of 5, right? All over 15. And that right there should be my final answer. Square root of 30 plus 9 square root of 5. Yep. Yay! All right, ladies and gentlemen, I hope that helped. I just want to review it really quickly. So notice just the general modus operandi here is that you want to take and you want to multiply the top and the bottom by basically whatever radical is on the bottom. You don't have to multiply the whole thing on the bottom, just whatever radical is on the bottom, right? So you want to do that to get rid of that radical. It'll move all the radicals to the top. Once you get to the top, you basically, if you can simplify, you simplify. Don't forget to distribute the radical in through the terms on the top, right? There's one example here. This is an example that I really love because it shows you that even once you're done, even after you've distributed everything, right? You start multiplying everything out and you start simplifying. What ends up happening here is you can factor out the 4. And I like that you had at least one problem where you saw that factoring out the 4, okay? Because that's totally cool. All right, any questions for Mr. Sims? I don't know why I'm asking, because you can't answer in the video. All right, hey, I hope you have a wonderful day today. I really do mean that. I hope you are starting to get the material that's starting to click for you. I'm going to post this video tonight, and I really hope it helps you for the test that we have on Friday. Once again, I always support you in your learning, and I really want you to be successful. So let me know if these are really helping you, and if there's something you know that would work better, or if there's ever a topic that you need, you let me know. If enough people request it, I'll prioritize that topic. Okay. So anyway, I wish you guys the very best of luck. As always, I think you're amazing. Keep up the good work, and I'll talk to you soon.